Good morning and welcome to the class once more. Today we are looking at functions and we are concentrating on the profit maximization model. From the first part, we are given the price or the demand function as 2650 minus 50q. We are also told the total cost is given as 1 over 400 q squared plus 150q plus 20,000. Okay, the requirement is given as follows. You are told to get the profit maximizing price. And it also asks to get number 2, the maximum profit. First thing to do is get the total revenue. Because we are told the profit is given as total revenue minus total cost, we cannot do the total revenue without getting the price first. We are given the P. We are told that TR is equals to PQ. Total revenue is price times quantity. And therefore, because we have the price, we can simply say it becomes 2650 minus 50Q. Then you multiply with quantity. It becomes 2650 minus 50Q squared. This becomes our total revenue. From there, we can now get the profit. The profit is TR minus TC, where TC is total cost, total TR is total revenue. Therefore, we can say it becomes 2650 Q minus 50 Q squared. Then we shall minus the total cost, which is already given as 1 out of 4 Q squared plus 150Q plus 20,000. Now 1 out of 4 becomes 0.004. So you can say 0.004 Q squared plus 150Q plus 20,000. All right. Now we can therefore come and say this becomes 250Q minus 50Q squared minus 0.004 Q squared minus 150Q minus 20,000. That becomes our profit function. Now, collecting like terms together, we have 2650Q minus 150. So we shall remain with 2500Q minus 50Q squared minus 0.004Q squared. It becomes minus 50.004Q squared, and then we have minus 20,000. This becomes our profit. The question is asking the quantity that will maximize profit or the price that will maximize profit. We can't get the price that will maximize profit until we get the Q. So we can substitute Q here. The price that will maximize profit will be given once we know the quantity that will maximize profit Q. And so we come and say, because we know at maximum profit, the dq, the differentiation of the profit function becomes 0 at maximum profit, and therefore when we differentiate the profit function here, when we differentiate this profit function and equate to 0, that's a quantity that will give us the maximum profit. And therefore, let's differentiate this. It becomes 2500. Then look at this. We are going to get 1. When you differentiate, we're going to get 100.008 Q squared, right? And then this should be equal to 0. That is the differentiation of the profit function. This means if this is our differentiation of the profit, then you can say therefore 100.008 Q must be equal to 2500, and therefore you can therefore say the Q becomes 2500 divided by 100.008. This gives me 24.99, and that is approximately 25 units. This is a quantity which maximizes profit, and therefore if I wanted the price that maximizes the profit, then I would go to the price and say price will be given by 2650 minus 50 times Q. But the Q has been found to be 25 units. And therefore, I can come and say the price now, the price to maximize profit will be given by 2650 minus 50 times the Q. And the Q we have found to be 25. This is 750 minus 2650. This becomes 1900, and this is the price that is maximizing our profit. Number two of the question was asking the maximum profit. The maximum profit is given by the profit function, which is 2500 Q. The profit function, which is 2500 Q minus 50.004 Q squared minus 20,000. Therefore, we shall say it becomes 2500. Q is 25, so we are replacing. Then we minus 50.004 Q squared. This is 50 squared. And then we minus 20,000. This is a function that will give us the maximum profit. Thank you for watching, and may God bless you.